Sorry, bro. You wouldn't stop. Okay. Okay, wait, can you check the stream now? Can you hear me at least? Like after 13 seconds. All right. Can you hear me now, by the way? Just type if you can hear me. Hello, hello. 1 2 1 2. All right, good. All right. 6 people in so far. Can you guys hear me? All right, perfect. All right, gonna put that on the side. Oops. Gonna start in 3 minutes. Perfect, perfect. Yep, we'll start in a bit. Can we start now, or we wait a bit more? All right, 15 people so far. All right, well, I don't mind. I can start right now. I guess here we go. We'll go slide share from current slide, display settings, swap. All right, good afternoon and good evening, everybody. So right now here we're doing the Introduction to Unity workshop. It's presented by the SCS and the Concordia Game Development Club. This is a collaboration workshop between two overlapping societies. So we'll focus on, I guess, in Unity pretty much. So first of all, who are we? Well, we're in the Concordia Game Dev Club, and our goal is to gather people from the university students who are interested in game development, and we teach people how to make games and also how to keep up with the latest game dev industry news. We have currently over 200 members on Discord, and we also do a lot of game jams, which are also hackathons, you can say, where we basically try to do every month or every few months, where I guess the whole club gathers together and we make games in a hackathon, let's say for a certain amount of time. And it's pretty much like a hackathon, but for games. So we do these a lot. We also do workshops as well for programming, art, or anything else related to game development. And we also do a lot of collaborations. Currently, we're doing with SES, but we also do with other universities at TES and McGill. So also I'd like to take the moment to thank SES for helping us host this workshop right here. It's our pleasure to collaborate with you guys. And you can also find our Discord links and Facebook. They will be posted in the chat soon as well. And that's where you can join us. And I guess let's learn Unity now. Oh, just one thing, by the way, before we start, there's going to be a GitHub link posted in the chat soon as well. So if go to that link, I want you to go to this button right here. If you don't know how to use GitHub, just go here and just download the zip file. I want you to do that because um, it should download while we're presenting. And hopefully that's straightforward. And just let it download while I'm presenting. It's going to take about 2-3 minutes to download and probably 5 minutes to present. So, all right, back to the presentation. So, first of all, what we cover in this workshop? We'll cover pretty much why Unity is so important and why is it something more than just making games, and why is also the most popular game engine when it comes to game development. And also, I guess we'll learn how to program a simple FPS shooter, like a really simple program, a really simple game where it will introduce you to the basics of Unity. But first of all, what is Unity? Probably many of you have heard about it. Oh, I'll post a link, yes, of course. Da, da, da. Yes, Unity is free. There's instructions if you haven't downloaded it yet, there's instructions on how to download it on the stream description. There's gonna be Unity Hub and also the Unity program, and of course the Visual Studio Code, which is a lightweight editor. But for sure, you probably have another editor. I'll just show you how to integrate that after. And yeah, Unity is free. All right, so like we said, what is Unity? It is a real-time development platform that focuses on 2D, 3D, VR, and AR visuals. And it's also used not just in games, it's used in many other industries like automotive industry, film industry, animation, architectural visualization, and also engineering when it comes to technical designs. And so far, there's also 2 billion copies of Unity games that are downloaded every month, which is a lot of games made in Unity. And also Unity shares the majority of the market share when it comes to game engines. So it's a really popular. The closest competitor is 17%, and that's pretty much the Unreal Engine, which is another competitor. And first of all, why is Unity so popular? Why is it so widely used in the game development industry? So first of all, it's also the fastest growing game development platform to date. So that means there's an ongoing growing community and everybody is helping one another to learn how to use it. There's a really thorough, well-written documentation, which makes it easier for beginners to use it. And it also gives everything that a developer needs in order to create their games. So in everything in a single package. So everything related to art as well, and programming, and also how to, I guess, sequence a film. Everything is done in Unity pretty much. And also it supports every operating system and every I guess device. So you can make games for PC, Mac, Linux, Android, and iOS games, and also web games. Let's say any Flash games. Well, I mean Flash is gone now, but you can make HTML games published in WebGL. So what we'll cover in this Unity workshop today, we'll introduce you to the Unity editor, which will show you how we'll navigate around the Unity game engine. And we'll also show you how to manage game objects within a single scene. So how to pretty much place items and how to use them. We'll also look at understanding prefabs and what are they used for and why they're so useful. And we'll also show you the most important part, which is how to write scripts, how to program, and how to attach them into objects. So if you haven't done it already, please go download the GitHub link, like download the zip file, and I'll show you how to open it in Unity. So if you download Unity Hub and you already installed Unity, like we showed you the instructions before, I assume most of you have installed it. If not, you can ping in the chat. So, so how do we do this? Once you downloaded the zip file, you can go extract that zip file to somewhere. So let's say you can go to the downloads and just let's say create a folder and just extract the zip file there. So once you've done that, really simply just go to add and just select the folder that you go. So in this case, I placed it here. You go, you open the folder, and then you're going to see all of these folders right here: assets, library, project settings, and user settings. You want to press select folder pretty much. Oops. Oh, you're installing? Okay. All right. If you're installing, it's fine too. You just go, you see the folder and you just select the folder. Oops, not working. Quick install Unity. No. Okay, yes, install Unity if you can. So you go to Documents, GitHub, Unity Workshop, and there you go. So you should have a window pop out that says that you have a project ready. So what you can do is just press that, and it should load Unity for you. The first load might take a while, but it should take a few seconds. If somebody's still loading, let me know. Is everybody okay so far? Am I going too fast, too slow? Yeah, by the way, Rose will help you in the chat if you have any questions. But so far, it shouldn't be that if you have Unity installed already, it should be really simple to just add the, to open the project. Oh yes, also the description of the stream was updated if you haven't found the repository yet. So like again, just to show you real quick, if you're still looking to download the repo, just go to the link and go download zip file. Yeah, it should open a lot faster than most. So like I said, if you're still unsure how to open the project, you should have extracted it into a folder. Just go to add, navigate to the folder, and press select folder. All right. I guess now we should start showing you what Unity. So first of all, what you see here, I've already prepared, I guess, a map for the sake of the demo. So you should already have, and you go to, if you don't have this open, you should go to scenes and just double click main scenes. May take a while to load or not, but it should load back here. One thing I want you to do before we start is go to edit, go to preferences, and if you installed Visual Studio Code or Visual Studio Community or any other editor you prefer using, you can even use Notepad if you want, it doesn't matter. Just go here and you're gonna open your preferred script editor. In this case for me it's Visual Studio Community 2019. Some of you, I've already told you to download Visual Studio, so you should do that as well. And then just when you're done, it's gonna load, close it, should be fine. And then now you're ready to write scripts. But before we do that, we want to first of all navigate you through Unity. So this is the default layout that you see. So we have the main windows, which is a scene view. You right click. When you right click and you move your mouse, you're moving around the scene. And with WASD, you move the camera in front of you. I assume that's pretty forward so far. Oops, we have some questions. You open up a lot faster. Yeah, it takes a little longer to load up at first. So to navigate through the scene, like we said again, just right click your mouse and just move it to move around. And WASD to move, translate the camera pretty much on the view. And now you can just fly around the world, like no clipping. And if you want to go faster, you hold shift and you move faster. So that's about the basics for the scene. Now, you're going to see in your first panel, there's going to be here called hierarchy. If you don't have that, simply go top left, you go to window, you go to general, and then you have hierarchy, which is also a key short, like a hotkey. But I assume it's already there because that's the default layout. So what you have here, it lists the objects that are already in the scene. So the hierarchy is basically managing the scene's state. So you have, first of all, the camera. So when you select it, you already see you can move it. And if you select an object, like the light as well, or if in this case the camera, you can translate it in the world. And you just drag the arrows and it moves translated to X, Y, Z. Oh, with that, for people who don't have a mouse, yes, I assume it's going to be a lot harder without a mouse to navigate. But for now, it's fine. You can just click your pad and you can move. But you don't need to move much your mouse. Just if you can place it somewhere, you can see the most map. I think the most of the map, I think should be fine. You don't need to move too much. And you can see here the map, which is pretty much all the objects that I placed in the map. They're already placed for so I guess the player to walk through. And there's also the light, which is placed there. It's the directional light that lights up the scene. So far, what you need to do to also know, if you don't already have the project panel, you can go here, Windows, General, and Project. So when you press that, it might pop off somewhere. You can just drag the window, by the way, and place it anywhere you want. So as you see, it in real time, it updates where I want to place the window. If you want to press it in the bottom next to somewhere, just leave it there, like this. And the project pretty much manages all your assets. So as you see here, the scene that we already pressed, if whoever hasn't pressed that you've seen, you can press it, but it should already be open. We have the textures, which we're going to use, or they're already used in assets. Materials, if probably there's some of these are not there, but they should be there already. Materials, which are the materials for coloring objects. And in this case, animations, but they're already implemented. You don't have to worry about these. These are just for the prefab that we already have, the object, the gun. They're already done for you. So what I want you to do, there's also another tab if you don't have a console. Console checks if you have any errors or bugs. They're gonna be popping out whenever there's one. And it shows you exactly when there's an error. And now the most important one that I want you to remember is the inspector. So if you click on an item, it's going to open some settings here, depending on the object. In this case, we have a camera. Also special about the camera, you see that we have a main camera display already, which is a preview. That's for camera is already there. But here you're going to see we have some settings. So it shows the name of the object, if it's enabled or disabled. We have a tag. In this case, there's already given one. We're going to talk about tags later. But most objects, which is the most important, is the transform component, which pretty much takes into consideration the position, rotation, and scale of the object. So let's say if I move, as you can see, when I move the camera, you can see this update in real time. And also important tools to remember, let's say if you want to move objects in the scene, we have the classic hand tool, which grabs the items that you want. And we have the move tool on the top left right here, which you translate the object. We have the rotate tool, which rotates the object in real time as well. So there's different gizmos you can see. And we also have the scale tool, which scales the object. In this case, the camera doesn't scale, but I'm going to show you after each tools what they do when we start placing objects. And another thing I want you to remember is we have global and local transformations for rotation. So let's say for the local, if I turn it to local and we go to camera rotate tool, you can see now the coordinate system for the object is displaying the local coordinate system rather than the global. And we have here the center and the pivot. It's two different things. The pivot is the pivot of the object, while the center is the center of mass of the object. But in this case, you want to keep the center here. Most likely, we're going to use that. So we can start implementing. I guess we can start making a game. So first of all, we want to start coding or making the player. So we're going to make the movement. What you can do is go to hierarchy, you right click, go down to 3D objects. These are going to be different primitives. So we have cube, sphere, capsule, cylinder, and all the others. For now, just use the capsule. So as you can see here, it spawned a capsule object. So it's a little bean, you can say we call them. So like I showed you earlier, we have these tools that you can move the object in the scene. You can rotate it. And with Control Z, you can undo changes, by the way. So if, let's say, I rotate a character, but I want to change where he is, Control Z to change the rotation. And we also have scale, which if you scale the item, it changes its size. And then we have a rect tool, which scales the object relative to the whole object. So as you can see here, I just scale it properly. But we won't need this tool for now. It's just the easy transform. Right now, we only need the move tool. So if you go here, top left, move tool. So right now, this is going to be where we're going to use our player. So right now, we can move the player to touch the ground. But for now, he's going to stay there. And now here, you can create an empty. An empty is pretty much an empty object, but has a transform in it. So you can do right click and just go create empty. As you can see here, it created a child object. The child object is pretty much relative. It does not have a global coordinate system, but its global coordinate system is relative to the parent, which is a capsule in this point. So easy way to remember this is the capsule right now is the parent object, and the one below it is the empty, it's the child object. So if let's say I'm going to name this, you can name it empty. And to rename this, if you want to rename an object, just right click it, go to rename, and it's just going to pop out an input text field. And you can write, for example, player. Press enter, and it should update the name as well here. All right, so this is going to be our player. But when we play, let's say we want the camera to move relative to the player. So if you're going to see a button here called play, which is the top middle of the screen. What it does is if you press it, it's going to go to this window. If you don't, next to the scene view, it's going to pop out a window called game. If you don't have the game window, just go window, general, game. And this is how your game view is when the game starts pretty much. That's how your game starts. And if I press play right now, nothing's going to happen because I only have the camera. It opens the camera view. So you can also, while you're playing the game, you can go to the scene view. You can go back to the scene view while the game's playing. So you can see anything that changes real time while the application is running. So since nothing right now, we're just seeing the camera. So that's good. Just stop playing by pressing play. So go back to scene view, and we want the camera to be placed. If you drag it, oops. A quick way to move this, you can move it like this. Just bring it right in front of the player's, I guess, face, you can say. So you can move the camera just about right for the player. What you can do is, do you see these little rectangles? It moves the object in two axes at the same time. So if I press this one, it moves it to the X and Y axis at the same time. So that's an easy way to move things. And since it's placed in front of the player, now we want the camera to move with the player. So what you want to do is go to the hierarchy. You're gonna see here main camera. You're gonna hold it, and you see it's gonna be having this like a line right here. It shows where you want to place it. In this case, you want to place it inside the player. So you make it a child. So each time when you move the player, you want to make sure that the camera is moving as well. So that's like the main thing. You can also reorder the objects in here, the empty and the main camera, and you can place it above the other one. Now you're probably wondering, what do you use the empty for? The empty is going to be used for the player to move on. So it's going to be a checker that checks where the player is placed upon the map. So you should drag this all the way down. So if you're able to navigate slowly, you want to press it right at the belly of the bean. So that's going to check us if the player is touching the ground or not. That's going to be coded later. So we have the camera. So if you play the game right now, you're going to see that the camera is placed in front of the player. So that should be the view of the player. All right. So I guess we can start adding components. So I guess a player to move, he needs a component. So what are components? First of all, if you go back to the player in the capsule, in the object, you see there's already some components here. We already have the transform, which like we said, it shows the position, the transformation of the object. And we have some others called capsule mesh render and mesh render. These render the object in the scene. So let's say if I go to the mesh render and I uncheck it, it disables the component. But we want to enable it so we see where we are. So we want to see the capsule, of course. And most important one is the capsule collider. Capsule collider is pretty much, it forms a bound around the capsule, like like you see here the green lines. This is like the collider. So this is where it will allow all the interactions to happen outside of that bound. So it will make sure the capsule is not penetrating any other objects, in this case the ground. So just to see if we have any questions. Okay, no, good so far. Hopefully everybody's following. So this is a collider pretty much. It makes sure it makes sure the object is solid and there's nothing that goes through it. So you can see here some settings. If you open the collider, you're already going to see here edit collider. It lets you edit how do you want the collider to be. So if you go here in the object and you left click this point, you can change the shape of the collider. But in this case, we want it to be the size of the capsule itself, which is already done for us. So we can just Control Z that, undo it, the change, and it's put back right here. So most important component we had to add is you're going to go here. It says add component. Going to player character controller. So you want to type character, and it's going to search for the appropriate components. So in this case, we have the character controller. So if you press that, you're going to see new settings. So what the character controller does is it interacts. It makes sure we have the settings available for us to move the player. So right now, if I press it, nothing happens because we have not enabled the keys for it, because we need to enable that. So we have the component here, and we're going to use that for a script to move it. So what I want you to do now is we're going to start, I guess, coding the player. How do you add the capsule? I just installed for me. Oh, if you still are unsure how to add the capsule, just go to hierarchy in the window, right click, 3D object, and you can see capsule. Press that and it spawns that. And just a reminder, the capsule can be moved with the tools here. So you can move it like this. Should be fine. All right, so let's start coding. Now, when you go to the project view, again, like I said, window, general, project, you want to add a new folder that we're going to have our scripts contained. So you see here, which is the root folder called assets, which is pretty much the root folder for the entire project. You want to right click that, go to top, create, and create folder. It's going to pop out a new setting, a new folder here, but it requires our name. So just backspace and just type scripts. So once you press enter, now you create a new folder where you're going to place your scripts there. So once you do, enter that folder by double clicking it and just right click, create C# script. So as you see here, it put a new script in our folder. A default name is new behavior script, but we're going to change the name, backspace, call it player movement. So there's no spaces between the words. You just type it all in one word. But I guess way to distinguish between words, you can just make a capital one. I put one in capital. So it says player movement. So as you see here, it popped in the inspector some options for a display. So it shows what's in the file so far. Unity already put some, I guess, lines, packages already in your script. So if you double click that and you've already set the editor, it should pop out in your editor right here. So whoever doesn't have the editor yet, just to remind you, go to Edit, Preferences, External Tools, and you choose your editor. In this case, I said before, you should have Visual Studio Code installed. But in this case, Visual Studio Community is the same thing. So close that. Go back to our script. And here is now, you're going to see these lines of code right here. But basically, what are they? Right now, we're importing the Unity engine package, which is also it's going to have all the keywords and all the important functions that you're going to need for creating scripts in Unity. And here we have also system collections and system collection generic. These, you don't need them, but they're already put there for you. And the fact that you see they're a bit dimmed, it means that they're not used. And you see, I'm sure you know, classes, pretty much a class is a template that we're going to use to create, I guess, a blueprint for an object. And as you see here, the name of the script is already there. And as we named earlier, player movement, it already does that automatically. Let's check if we have any questions so far. All right, and then you see here a colon with a mono behavior, which it means that it's taking information from a base script. In this case, mono behavior contains all the information for a game object. Like you saw earlier, like a capsule, that's a game object. A mono behavior contains all the components, like the basic components like transform and the collider that we saw earlier. And you're going to see here two methods called start and update. There's already some comments there, which Unity already has there for us. So what do they do? The start function, when you open the game, this function is called right away. So as you can see here, start is called just before any of the update methods are called. And also update is called every frame. So since we have mono behavior, it means that each frame there's going to be a change, or at least an execution of a code. So these are the most important functions we're going to need. So like we said, start happens at the beginning of the object of the scene before the update, and right after that, it's update. So every frame, this function is going to be called. So that's why it's called a callback function. So right now, we want to start, I guess, implementing all the behavior that we need. So what we want to do is, first of all, we go here to enter our variables, our fields pretty much. And we want to reference the character controller component that we added to the player. So we create a variable, it's going to be of type character controller. If you already integrated the editor correctly, it should pop out options. In this case, we want the character controller one. With the up and down arrow, you can go through the options. And when you press enter to the one you want, it already types it for you. And then we just space. We want to name it player and put a semicolon there. So in this variable, we will have our reference to the character controller component that we added right here. So if you go to the player, we want to reference this component right here. So if you go back to the editor, we want to find that component. So how do we find it? We want to make sure we have it before any updates happen. So in the start callback function, before the update is executed, you want to assign that component. So in this case, do player. So what do we assign? So an easy way to get the component of the current object is do get component. So it grabs the component found inside that game object. Then here it asks for us to put a generic. That's why we used the generics earlier. That's right here. So we pass in here, what is the type of the component? In this case, character controller that we said. And since this is a function, we put a bracket pretty much, and we close it. So right now, it's once the object starts, we're going to get that component in the player. So right now, to test this script that it works, go to the player, scroll down, add component, and search for the script player movement. Press enter, and it already pops out the script here. So we already have the script integrated to the player, to the capsule pretty much. So if we go back here, now we want to start adding variables for the movement of the player. So now we add a vector type. So vector3 is pretty much an array, you can say, of three variables. So for the x, y, z, vector3 takes into account those three variables that we see right here. So vector3 is position that you see right here, all these three variables, x, y, z, they're stored into a class called vector3. So vector3, we're going to call it movement, which is going to take into account the transformation of the player. And we got an error here. Oh, ambiguous. If you got this by accident, just removed it, because that's something else. So this variable where we're going to update the player's movement every frame. So we want to move the player. So how do we move it? We create a new function. So we go under update. So we're going to call it void. Void means there's no return of the function. So we're going to call move player. We're going to call that. It's not made yet, so it's not going to pop out anything. Just put the brackets like a normal function, and just put the brackets to close the function. So right here. So right now, we want to, what are we going to enter there? We're going to be updating the movement every frame, yeah, right? So we're going to do movement. So we have to assign something to it. So what are we going to assign? We want to assign, I guess, the axis of the movement while it happens. So if you go back to Unity It should compile now. That's why it's loading. So it was making some compilations. Uh, and then go File, no, Edit, Project Settings, and you're going to go to the Player section. No, not Player section. Input Manager. It was already there. So you can see here there's different options that are already there for us. So we have horizontal and vertical. So these take into account the movement of a player. So they're already set for us WASD. So they're already named horizontal and vertical, but in this case could be front and back. And they're already put buttons for us. So up, we have the W, which is gonna make us move forward, and in this case we have A or D to move left or right. So this is going forward, backward, and the one above goes left and right. And so since this is already done us by default in Unity, we can just retrieve the information that's already there. So to movement, we open brackets and we do transform, which is the transform component that the class already has that's due to the mono behavior class, wherever you put, and do right. So what does this do right? Right, it creates a vector that is going to take into account the axis left or right of the object, but that's going to be multiplied by the input that we add. So input, we checked earlier the input manager, get axis raw. Basically this we get is the direction of the movement that's happening. You want to open a parenthesis since it's a function, and then you would do shift quotation marks to add a string in it, because it, as you see here, the function, it takes a string in it. And we type, as we saw earlier, the name of it, as we saw here, project settings. The name of it is horizontal, so that's the name of it. So we want to pass that as a parameter. So we do horizontal. So that's going to take into account the horizontal movement of the player. And we also want to add, now I'm going to add the I guess the front and back, which in this case is called the vertical. So we open another parentheses, transform, forward now, since we're going back and forth. And you multiply that by the direction, which in this case is get axis raw. And you open that and you put as a parameter a string called vertical. And then you close the function, you close the assignment by putting a semicolon. So now what this does, it takes into account the direction the player is going to be moving based on our input, like our keys, WASD, which is already done for us in Unity, is going to calculate the direction the player is going to move. But that's just a direction. It does not take into account the movement. So what we want to do is create variables that are going to change the movement, and let's say relative to a speed or relative to each frame. So what we want to do is create variables. We're going to create public float. So float is like a double, so it's like a decimal. Speed, we're going to name it speed, so that's how fast the player is going to move. So under this movement, we want to call a function that moves the player first. So we already have the character controller, so do player, and then press dot. And we have functions here that the player component already has for us. So we do move, and you put this a function, you put brackets, you put the movement, the direction, which we already put. So as you see here, the function, it wants a vector 3, which is our movement. We already entered that. But we also want the speed. So in this case, speed is the variable that we already listed on top, and we're going to change that later. What's the number of it? And now what is important is to multiply it by a variable called time delta time. So time delta time, so if I type it, time dot delta time. So, and close this function. So what time delta time does is how long a frame takes to change. So in the update function, where it's called every frame, so how long does it take for that frame to change? So why is this important is because each computer has different refresh rate, or different programs have different takes different space on the CPU. So that's done for us. So that's an easy way to not have destructive movement while we're testing a different monitors or different computers. So since we already moved our move function, we can just call that function to the update. So it's going to move the player every frame. So we call move player, close the bracket, and that should be the movement for now. If we go back to Unity and we start the game, Oh, we need to set the speed. Oh, my bad. So we go to player. You're going to see here, we got any compilation errors? Oh, we done not save. We need to save first, so save it, whatever editor you're using. So it's going to compile. And you're going to see an update on your script. You're going to see it's the variable speed that we added earlier. So that means we have to set a variable for it. In this case, we can set it to 5. So it's a variable, it's the speed that the player is going to be moving. So if I enter now, it should move. There we go. So if you press WASD, it moves the player left and right. I assume that so far should be easy. And what is the shortcut? Any questions so far? Wish off for opening code editor for the window. There's no shortcut, by the way, to open the editor. Whenever you press the script, it opens it for you. And all right, as you can see here, if you play the game, like you press here, it pops out the game window, and you should be moving your player with WASD, or even with the arrow keys, you can move it. So you're already moving it left and right. So good so far. So this is our player movement script for now. But we also want, you also couldn't associate script. By the way, if you're having, probably the reason why you can't associate a script is because you need to fix all compilation errors, and you need to search it when you go to add component and player movement. You select it. So you type player here and you select it. And all right, so we got the movement down. Now we want to get the rotation of the player, which is another script we're going to make. So create new script, and we're going to call it, in this case, player camera, because since the player is going to be rotating the camera, so that will be our rotation. So we create a script, same update here, the same default function. So we open that. And we have the same options that we see: start, update, mono behavior, and Unity engine. So right now we want to set up the camera rotation for the player. So we need to set up variables that are related to pan, tilt, and rotate the camera. So this one is a bit more complicated, but it can be done. So first of all, we need to store the variables for the camera X and Y, which is the rotation. So do float, which is a decimal in this case, camera X. So cam X, that's the how we're going to differentiate it. And for the Y-axis float, cam Y. Now this will take into account the movement of the mouse and will rotate the camera based on the movement of the mouse. So right now we need to create a function, void, there's not going to be any return, move camera. You make it on function and you open it here. So we want to change these variables, cam X. So the same way we did it for the player movement, that we use it input, the same thing we're going to do for the camera, but this time we're going to use the camera input. So we're doing input dot get axis, not get axis raw, open brackets since it's a function. You open a string and you typing mouse X. So basically, why do we put mouse X? So if we go back here, in the edit project settings in input manager, you see that we already have mouse X here and mouse Y for us. So these basically are Unity has provided the input for us to change during when we code. So this takes into account the mouse movement while you're moving the mouse in the game window. So for CamX, for sure, we're going to associate it with the mouse, with the X movement, X coordinate axis. And now we want to multiply it by time, delta time, like we said earlier. It has to take into account the time delta time for each frame. But we also want to save, we want to put a sensitivity to it, which in this case, we're going to name float cam vert. So what this does is it's going to change, it's going to clamp the movement of the vertical movement. So sometimes when you rotate a character, you don't want your head to turn in the other side. So you want to pretty much limit the movement of the head, just like in real life. So we're going to simulate rotation of the player's head pretty much. So we want to multiply it by this because we want to make sure the limit is set for the camera movement as well. Because our heads do not turn 360 degrees when we're turning it up and down. It has a limit. And so what we do, we want to set that limit. So we do cam vert. And now we have a class called mathf. Mathf takes into account all the mathematical functions. They're all put in a single file in a single class that are done for us. So mathf, we do dot. And this is the most important function called clamp. So what clamp does is it limits a value within a certain minimum and maximum. So let's say in this case, we're going to be changing the degrees of the angle. So what this does is it makes sure, let's say, if we set a value for the rotation of the head, it stays within a certain minimum and a certain maximum. So if we enter clamp, it has three options. We have the value that we want to clamp, and we have a minimum and a maximum. So in this case, we pass cam vert, which is the value we want to limit. And what is the minimum and the maximum? This is what we set. So in this case, we create a new variable called float cam, we call clamp value. So in this case, by default, we want to set it to 70 because that's a constant that's going to stay there. And also we want to set it to 0 the cam vertical, we want to set it to 0 degrees. So our head, when we start the game, is already at 0 degrees. So when we go to cam vert, here now we need to set the maximum and the minimum, as you see. So in this case, we already have a clam value. So 70 degrees, we set the head. It's going to move only 70 degrees up and down. So an easy way to do this is it's going to go to minus 70 degrees. So minus clamp value. And the maximum is going to be clamp value. So what that means is our head is going to limit its vertical rotation from minus 70. That's why the minus there. And plus 70. So it will not be able to move within those angles. All right, so we have already set that. But now, since we clamped that, we want to change that camera. Now we want every time there's a change in the input get axis mouse, which is called every frame, we want to associate that with the vertical movement. In this case, we do minus. We do minus equals, so cam y. So basically what this does is exactly this, which is cam vert is equal to cam vert minus cam y. So the above assignment is I guess a shortcut of this one. So if you put the minus next to the equals, it just deducts this amount from this one. So now we have this, and we also want to do this input get axis. We only have it for the x-axis, but we want to set it for the y-axis as well. So cam y is equal to input get axis, open bracket, string mouse y, which is the name of it, time delta time, like we said, and that's it. Oh, I think actually this one is wrong. This, like we said here on the speed, like we have speed here. Here we're going to have mouse sensitivity because it's going to be rotating. So I'm going to name a variable called, we're going to call it public because we want to edit it in the inspector. One thing I haven't mentioned yet is by default, the reason why I didn't put public and private in these is because by default, Unity sets them to private. But since I want to edit it in the inspector, which is on the panel that you saw earlier, we instead it to public. So it's public. So mouse sensitivity. So that's going to be our variable that's public float. So that's going to be the variable that's going to set the sensitivity of the mouse while the character is rotating. So we want to multiply that by the movement. And we're going to do the same thing for the vertical as well. So copy that and just paste it here. All right, so we have set up the mouse movement, and we also have, we clamped the camera to the vertical axis so the camera does not move. And then we have to just set up the function that rotates the camera. So we do cam. We want, all right, we need to reference the camera, of course, because if we go back here, this script will be attached, we'll be using the camera. So we need to get this component right here. So what we want to do is create a new variable, a new reference, you can say called camera. So class called camera and name it cam. And like we did earlier for the player component, for the character controller, we want to do the same thing for the camera. But in this case, it's going to be different because we're going to have cam is equal to get component. But since the camera, we set it as a children, since the camera is a children of the player, we're going to use the following. Get component, scroll down, and you're going to see in children because we want to get the children. And then you put the camera type in it. So that should, before every calculation is done, make sure we get the correct reference of the component. So now do cam dot transform, which is going to take into account the transformation of the camera. Dot, and we're going to get local rotation. Now local rotation is going to change the rotation of the camera in local coordinate system. So since it's a child, since we said the child, it takes into account the movement of the parent. Is going the rotation of the camera is going to be based on the player coordinate system. So we open a bracket, and now we set. Oh no, now this is just we're going to assign that. Sorry. So now we're going to do quaternion. So what is a quaternion? It's basically how rotation is interpreted in the form of angles. So let's say here, you see here rotation X, Y, and Z. Now for quaternion, what's the difference is there's an extra value that takes into account the angle, which is pretty much the degrees that we're going to change it. So dot Euler, we want to turn it into X, Y, Z angles like we saw earlier. And we want to now move the vertical movement, which is the up and down of our head, which is our pan of our head. So we're doing cam, the vertical that we clamped right here. And for now, we set the X, the Y, and the Z to 0. So 0.0f, 0.0f. So right now, if I go to the update and call move camera, because it should be called in the update, which is going to happen every frame. If I go back here, I have to attach the same way we attach the player movement camera. We have to attach it to the player camera. So I'm typing player in the add behavior button, and you see player camera. We enter that. So what this does now, we see here, we see the mount sensitivity variable that we set public earlier. So we set a sensitivity that we want our mouse to turn. In this case, we can put 50. So we can test that by going to game, press enter. And now in the game, you see my camera, if I move your mouse or your mouse pad, you see my camera is moving. And what we did now, if I scroll down, my camera does not no longer move under my belly, just like we said earlier. You don't want our camera to move in under our head because that's impossible. So we got that. So if I do both now, we already got the movement and we got already got the tilt of the head. But now we want to move the camera, and we want to move horizontally as well. So we got the vertical movement down. So now going back to here, what we want to do is transform. We want to rotate the player left and right. But in this case, instead of rotating the camera, we'll rotate the player itself. So we'll do this right here. So if I go back to scene view and I select the rotate tool, we'll basically be doing this. We want to do this, which is pretty much turning the y-axis, which is the green axis. So similarly to what we did for here, instead of moving the camera now, we're going to turn the player itself, which is going to be easier. So we do a transform, which is a transform of the player. You don't need to reference, usually you want to reference this, but you don't need to do that because the player already has a mono behavior script on him. So since he already has a mono behavior, you can just reference transform right away. Transform dot rotate. So what difference between local rotation and rotate is local rotation, it sets the rotation to a specific variable that you want, while rotate is actually rotating the object towards an angle that you want to. So doing rotate. So like we said earlier, like the classic we've been doing for setting a rotation or position, we set the direction and we set the variable that we wanted to. So in this case, for the movement, for the horizontal movement, we do the direction, which in this case is vector 3 dot up. So basically, vector 3 dot up means is a vector 3 of 0, 1, 0, which if I go back, is going to rotate along the y-axis, which is this one, the green one that they want. So vector 3 dot up, but we can have others. We can have vector 3 forward, which is the z-axis, but in this case, we need up. We multiply that by the camera value that we set in earlier. So we do camera x. Now we should be able to turn the camera in all angles, but one thing I want to mention is the cursor has to be locked before when we turn the player. The reason why this is important, so do cursor dot lock state. So basically we want to make sure the cursor is locked with the game view of our screen, because you saw earlier when I was playing the game, my cursor was running off the screen, and we don't want that. So we do lock state is equal to cursor lock mode, which is a class that's going to give us a state. So we have 3 states. If you press dot, we have confined, locked, and none. We want to lock it. So we do this. One thing I would like to also mention, instead of start, there's also another callback function similar to start, which is called awake. So what awake does, what's the difference between awake and start is awake happens when the script instance is loaded, while start happens right before the update function starts. So the main difference is when the object is loaded, this is executed before the scene starts. So that's the main difference. We want this to happen before the scene opens. So if we go back now and replay, so if I click in here, you can see I can turn my camera, just like we said, and pretty much I can move just like a player. So this is pretty much our first person movement. So press escape to cancel, and you close the game view. So we pretty much got our movement right here. Now we can move to the gun. I guess we can start implementing the shooting. So what we do now, there's already a model for us. I prepared a model called, it's a gun. So you want to go to Assets, Models, FBX, just hold the gun and drag it in the scene. I know, yeah, it's pretty big. So, but we can change that. So this is a gun model that I prepared for this tutorial. So what I want you to do first of all is, of course, change the scale. So go to Transform, like select the object, Transform, Scale, and change it to appropriate value. In this case, I'll put 5. Is it too big, too small? I think it should be fine. The gun should be 5, yes. And then go to the rotation, and you can rotate this to go alongside with the player. A better way to do this is set this, go to the Z and set it to 90. In this case, minus 90. So you can just change the variable right here, or you can drag it. You can just hold the Z variable you see and just drag it. That's another easy way to change the angle. But for this case, we want this. Now, we want to place it at the hand. Well, there's no hand in this case of the player, but we'll pretend that he has one. So just drag it just about right. A good way to check if the gun is placed correctly, go to your game view, and it should be around here. So what I can do is go here, and what I want to do now is place the camera inside the player so it rotates correctly. So what I want to do is go to Transform. I'm going to see 3 dots right here. I'm going to press Reset. It's going to place the object in the middle of its parent, in this case, the player. If there was no parent, it will place it in the world view. And now just drag the camera back up at the head, and it should be there. Now you can see the gun in the viewport view. It's right here, but we can place it better. We can go to gun. What you can do also, if you want to do both at the same time, just go to the game view, grab it like we said earlier, just put it right here. And you have both at the same time. So now I can place the gun. You can place it however you want. I'm going to place it like this. So now we got our gun. And now since I placed our gun, what I want to do is put this back up in the view. I want to turn this into a game object. Right now it's not a game object. It's just an imported model from another software. So do right click, go to prefab, and unpack completely. And it turns it into its own independent game object, independent from the model that we have here. So we have a gun. Now, what we want to do is, an easy way to not rely on the coordinate system of this gun is to create, okay, it has its own cube models and all that. We want to create an empty as a parent, because we're going to use that empty to move the gun. So we're going to create empty, parent. So it's already done for us, you see. It puts an empty above the gun. And we want to rename it, call it gun. I guess a way to differentiate between the empty and the gun is just rename the gun into gun model. So the gun model is placed on the coordinate system of an empty object. What I want to do also now is, I guess if you have a problem like this, just go back to the gun model, press reset, and it puts it inside the empty. This is the empty right now. Now, as you see, it's pretty small, the gun. We're going to change that. We're going to set the variables. So if you can put minus 90 and minus 90 right here. So this is our gun. Kind of small, I know. So if you have problem again with the size, just go back to the gun model and set it to 5. Because by accident it was taking the scale of the empty. So now we have back our gun. Place it back accordingly how you want it. There you go. Place it here. Should be fine here. Place it a bit forward. Okay, there's a gun. So as you see on our game view, the gun is placed as a first person gun, like we're holding it ourselves. So what we want to do with the gun now is since I already prepared animation for the sake of the demo, I want you to add an animator component. So go to add component, add animator. So these are different options that are used for animating the object correctly. So what I want you to do is go to controller. You're going to see here a circle dot. Press that. I've already prepared a gun animation controller, which I'll show you what it is. So just click that. And now what I want you to do is go to Windows, go to Animation, and go to Animator. So it's going to pop a window on the side of the panel here. So you see there's different states of the gun. So we have different, guess this is the animation state machine. So it takes into account different states of the gun. So we have gun idle, which when the gun is just hold it in the hand. And we have gun reload, which plays an animation. Here the animation, we have motion, which plays a reloading animation. And here we have a gun shoot animation, which played as well. So basically these arrows indicate the flow of the animation. So the orange one is the default one. So that will be played from the beginning. And it's also looping animation that I said earlier. And every time we enter a key, we want to make sure that, let's say if we want to reload a gun, we want to, for example, press R and it reloads the gun. For us, it plays the animation, then it goes back to idle. And then same for shooting, when we press, let's say, a button that shoots a gun, it goes to this animation and then goes back to idle. So pretty much this is what we're going to do. So go back to the gun. We have the animation controller. And now we want to create a gun script. But for now, if you want to see how it looks like, just press play. Oops, our gun, where's the gun? Oh, right. You must make sure the gun is placed inside the player. So I want you to go to gun. Place it in the parent of the camera because we want to make sure our gun follows our head. So if you press play now, this is our gun, but it's placed in the wrong position. We're going to change that, but you see it works. So just reset these variables to 0. Oops, again, it's not set correctly. So let's say -90, 0, go to the gun model. We do -90 and 90. Do this in the model instead of the gun empty. So we have our gun up -90. We have our gun pointing correctly to the right direction. Let's see now. There we go. So this is our gun. It plays the idle animation as you see now. It just bops the gun up and down. So we want to play the shooting animation and the reload animation. Hopefully if we have enough time we can do both. But for now let's try the shooting. So what we want to do, we want to create a gun script. So go to script, right click, create script, and we're going to name it gun. And we open it. So we have the same callback functions as you see. And let me open my reference. Okay. So now we want, in order to play these animations how we want to have a reference to the animator controller that we showed earlier. So we do animator, gun animator. So we need to get that component the same way we did for the camera and the same way we did for the player movement. So we have void start. We do gun animator, get component. We're just going to do get component because this is going to be attached to the gun object. And we just put animator. So now we're able to control the animator through a script. And now here in the update method, we can create a new function called, we can call it shoot gun. And we're going to set the correct, when we're pressing a key, in this case, left click, it's going to shoot, it's play the animation. So we're doing if input dot get mouse button down. So when there's a click and it asks for an index, in this case, left click is index 0 right click is index 1, and the middle click, if you have one, is index 2. So we have that. So we make an if statement, and we want to make a function called shoot. So we're going to name it void shoot, and that function is going to play the animation. So for now, and we're going to do gun animator. And now since we're accessing the animator, we can just play. And now what it asks is the string name of the animation. In this case, it's called gun shoot, which is pretty much, if it loads, we want to call gun shoot, which is this one right here. It has the animation called gun shoot. So we want to access this state right here. So we're doing gun shoot, and it's on layer. Here in the layer, there's only one base layer. So layer index, that's asking for a layer index, we just put 0 by default. So now, whenever I press, and now if I call shoot, so whenever I press the left mouse button, it should shoot. It should play the shooting animation. So in this case, in the update method, we do shoot gun. So now I compile the script, go back to the scene view, start. And now, whoops, not playing. Should play the animation. Why is it not playing? Because we're actually in the gun shoot, gun animator play. It should play the animation. Get mouse button 0. Correct. Shoot the gun. Correct. Let's see now. It's not recognizing the click. It should shoot. I don't know if it works for you guys. And gun shoot. Oh, did I set the? Oh, we didn't set the script. All right. Well, we just need to set the gun. Go to the gun empty, by the way, and just set the gun. There you go. So now if I press it, there you go. Whenever you click it once, it shoots the gun. So this is, for now, just the animation. We haven't implemented any shooting logic yet. So now if I go back, that's why the reason why I separated into two functions, because we're going to add more stuff here. So we have the shooting. I guess and now we go to, I guess we want to reload. So we're doing the same thing. Since I realized we don't need this function, you can just copy paste this if statement, remove the shooting gun, and just paste it right away into the update function. So we don't have two functions. And now we want to do the same for reloading. So we do if input, get mouse button down. No, not get mouse button. We want get key down. So now we pass the key code, which is in this case doing key code .r. We want to reload with the R key. So we open the if statement, and we're going to call a function called reload. Oops, it's not typed yet. So we go here back, void reload. And now we should put an animation called reload. So it's called gun animator play gun reload and layer index 0. So now if I go back here, I can shoot, and if I press R, it plays a reload animation, which is pretty much, it's like going up and down the gun for now. So we have the animations done, and now we can start implementing the logic for shooting and reloading with having clips and bullets, and we're going to add those. So what we run right now is we want to set the clip size that we have. So we're going back here, going public clip size. So we want the amount of bullets that we add. So public int So it's an integer, it's a number of bullets. So clip size is basically, I guess the logic, I'm sure probably most of you know, realize, is we're going to decrement every time we shoot. We make sure the clip is being, like we're decrementing bullets. So the way we do this is we create another variable called private. In this case, we don't need to change it through the inspector. Int current clip size. So that's going to keep track of the clip size that we currently have. So far, whenever we shoot, we want to make sure we set current clip size, we decrement it. So far, I assume it's pretty straightforward. But in the beginning, we want to make sure before we start the game, we make sure the current clip size is equal to the initial clip size that we already set. So if I go back to the gun, we have a clip size here that we can set. So I guess a gun we can set 7 for now. So we can say 7 bullets. And when we go back to Unity, now what's going to happen is at the start, it's going to set clip size to the current clip size. It's going to initialize it to 7. And each time we shoot, it's going to decrement it. So 7, 6, 5, 3, 2, 1. But we have to make sure it does not go below 0. Or we have to make sure the player cannot shoot while he has 0 bullets. So we have to set another if condition for that. So to make sure we shoot is we go in here to the shoot, and we have to set another condition in the if statement that says get mouse button down. So we want to make sure when the player is pressing the key, but at the same time, whenever his current clip size is bigger than 0. So if he has 0 bullets, he cannot shoot. That's a way to do this. So we set that. So if I go here and I play it, okay, 1, 2, 3, 4, 5, 6, 7. I can't shoot now. After the 8th one, I can't shoot because I set the condition that does not let me shoot afterwards. So that's set. But now we also want to set the reload correctly. So now I guess we have to reload the gun. So each time we press R, we make sure we set the clip size to the correct clip amount. So we go to reload, current clip size. We're going to set it to the initial value that we had it, which is clip size, in this case 7. So each time I go back and play, so 1, 2, 3, 4, 5, 6, 7, I can't shoot, press R, it reloads, it plays the reload animation, and I can shoot again now. So we set the bullets, we set the management of the bullets correctly. Now we want to make sure you cannot shoot while you're reloading. So right now, if you go try it back, so if I reload, I can play the shooting animation, which is not what I want to do. So we went to set a timer that disables the animation while, once it disables shooting while we're animating. So to do this, we need to set 2 variables called, so if we set a comment here with double slash, so we've got reloading properties, I'm going public, we're going to set a reload time. So that's the amount of time that will take to reload. So public float. And then we're going to set another private variable. So in this case, no need for a public or private. Again, float. And reload cooldown. So this will be used to check the current time the reload is taken into account. So we want each frame, whenever the game plays, we set the reload cooldown. We want to decrement it from time delta time. So let's say, for example, I set the reload time to 3 seconds. It will take for 3 seconds for reload cooldown to reach 0, which is exactly what we want. So like we said, it just the same thing for time delta time. It makes sure that it takes the amount of seconds or milliseconds for a frame to change. So that's why we want to decrement it by reload cooldown time. And we also want to make sure in the reload, we only reload once, and we don't reload when we're already reloading. We want to make sure we don't call another reload call. So we're going to make sure that when the player can reload again is when the timer has reached 0 or below 0. So if I go now back and I play, I shoot, I reload, I cannot, now if I press R again, it does not call reload again unless the current one finished. So what we want to do is go to the gun and how much the reload time is. For now, we will set it to we'll set it to, I think, let me check the variable again. The reload rate is 3 seconds because that's how long the animation is for the reload. So just to remember, 3 seconds until we reload the next time, the minimum. So that's done. So now we want to make sure we do the shooting function. Let's go back. And all right, we said now we need a shooting cooldown because if I go back and play, I can shoot every frame without having the animation finish, which is not what we want to do. So we need to set a same cooldown for the shooting. So we're doing shooting properties. So we're doing public float shooting rate. So it's the rate of the gun that it shoots. Like in real life, different guns shoot at different rates. So right now we're trying to set a shooting rate for that. And then we're going to float shooting cooldown. All right. So the same way here. The reason why we don't want to set it to the shooting cooldown to shooting rate in the beginning is because we want to make sure we're able to shoot when the scene starts. So the only thing we need to do for this one is go back to the update function and just shoot cooldown minus equals time dot delta time. And we also want to set the condition for it. So I'm going to the shoot method, and here we have the conditions. We're going to call the shoot function when the player presses a key, he has enough bullets to shoot, and when the cooldown has reached its correct time. So we're doing shooting cooldown is less than or equal to 0, the same way we do this. So if I go now back to Unity, if I can set a shooting rate to 0.1 seconds, so that means that it will take 0.1 seconds until you're able to shoot again. So 1, 2. So now if you see, and guess if you time it correctly, the amount of bullets that leaves the gun is the same amount the reload time takes, the shooting rate. All right, so we have that. So we set both cooldowns correctly, so we're able to shoot the gun correctly. Now we can implement a correct shooting. We can correct a shooting ability. Just one thing I realized, because the shooting rate takes into account also the amount of seconds the animation takes, we're going to set that to 0.3 because 0.3 is how long the gun shoot takes to finish. So now we want to slowly implement a shooting mechanism. So what we want to do is go back to the shoot function, and we're going to show you now a new component called like raycasts. So basically raycasts are imaginary lines that are shot from one direction, and it detects the objects that it hits. So if we go back to the scene, the gun is going to shoot a ray and is going to touch the closest object with a collider. So if we want to make sure when we shoot a ray, it detects that there's something in front of it. In this case, we have the wall. So basically, think of it like lines, pretty much. Basically, imaginary lines that are shot in order to detect what's in front of it. So if I go back here, we can do raycast hit. So there's two components. We need the raycast line and the raycast hit. Basically, raycast hit is the hit detected when the line hits another object. So going back here, so we're going to raycast hit going to initialize the variable. And we're going now to create an if statement that checks if that hit is detected pretty much. So each time we shoot, we're going to check if that ray has hit somewhere. So I'm going to call a class called physics, which takes into account everything related to raycast. Going to call the raycast function. So if the raycast, now we need to set where does it start. So there's many different arguments. Where does the raycast start? The direction, and also to hit it, where does it hit? So what we want to do now is go to the player, go to the gun, and to the empty of the gun, and I want you to right click, create an empty. Now that empty will be the start of the raycast line. So we're going to call it nozzle, so because that's where the gun shoots from. And like the tools that we showed you earlier to move, just grab the little cube right here that you see, the blue one, and just place it in the nozzle of the gun. Needs a bit more precision, but it should be something you can do it however you want. So that's going to be where the line is going to start. But we want to reference that. We haven't referenced it. So we need to go up here, and we're going to reference the same way we did for the animator. So we go in to do a vector 3, a transform. We want to reference the transform of that nozzle. So nozzle. And if I go back now here, I go to the gun. Oops, I need to set that to public since we want to change that through the inspector. Oops, I got a compilation error. Oops, where's the compilation error? Oh, okay, just comment that for now because we don't need it. So when it compiles collectively and there's no errors, going to the gun, going to see the script here, there's a drop down, or at least the option here. So go to the nozzle that we have, drag it, and place it into the nozzle variable. So as you see here, change it. It means that it references this object right here, the transform. So now we can reference that in the script. So you can go back here and comment that. So here the arguments say the origin, which is nozzle that we said, transform, and dot position. So the ray is going to shoot from that nozzle that we saw earlier. It's right here, from the nozzle. Go back here, transform position, and what's the direction? So nozzle, dot transform, dot forward. So in the forward direction, which in this case forward is the blue line, which is the z-axis. So it's going to shoot the line towards that blue direction that you see. So now we want to reference where is it going to hit. We're going to write out hit. Basically what it means is it's going to automatically detect if it hits something or not. So this is basically a Boolean function. It checks if this is true. So we're saying if the ray that we initialized hits somewhere. So that's what the if statement is. So if it hits somewhere, we open that. But now we also want to make sure that it's hit somewhere. So what we want to do now, go back to our scene. We want to set targets to shoot at. So what we can do is close the player, create, and go to right click on the hierarchy, 3D object, cube. I guess it will be our target. So created a cube object here. You can move it, and you can place it in the scene however you want. I would suggest if you scale it up, so put it scale 3, so it's a bit bigger, and so we're able to hit it. And it as you see, it automatically has a collider the same way the capsule had earlier. So what we want to add now, we want to make this object interactable and give it, I guess, a real-life physical properties, you can say. So there's a component for that called rigid body. So it makes rigid body basically simulates Newtonian physics so gravity and any forces applied to the object. So we want to basically, our goal is to, whenever we shoot the gun, make sure this object reacts and is pushed away. So here, as you see settings, we have mass, we have drag, angular drag, and if it uses gravity or not. These are default, good for now. And these are all the information like speed, velocity, and angular velocity that we already have. We just need to add the rigid body component because that's what applies physics to the cube. So if I start the game now, as you see the cube up, it fell down on the floor. So I guess if you want to see this while we start the game, just move the cube right here. And it fell down right in front of us. So basically what we want to do, since this is our target, we want to set that as an object where the gun can shoot and it can interact with. But to do that, we want to make sure we set a tag. So you're going to tag. Basically, tags is if you want to group objects together under a certain category. So, and tags makes that easier. So we're going to add tag. It's making a new window in the inspector. Going to see sorting layers. And we have here drop-down called tags. There should already be a tag called target, but if you don't have that, just press the add sign, type target, and press save. So that creates a tag for us. And we want to apply that tag to the cube. So we're going to tags. It's currently untagged, and we want to select the target. So now this cube is labeled as a target. The reason why we set it as a target is because we make another condition that makes sure the gun shoots at that target. So going back to script in the gun, the hit, we're referencing if the hit is successful, but if the hit is also transform, now we're going to compare that tag. So we're going to check if the tag is target. So as you see, we're doing hit, that transform, which is the mana behavior that we said right here. And then there's a function called compare tag that passes a string, which in this case we want to check if the object that we hit is a target. And to do this, now we check if that's true, but then we also want to check if the object has a rigid body on it. So we do hit dot transform dot get component, and we call it the rigid body. So now and then we put an end statement. So there are two conditions that we need to check: if the object has a rigid body, and if the object is labeled as a target. So we close that up. One thing I want to notice is you also need to set it to check if it's null or not. So null means if the object is empty. So that means we're checking if the object that we hit is labeled as target, and if the rigid body on the object exists, we check if it's not null. So we have these two conditions. If those conditions, both of these conditions with the AND statement is true, now we're going to shoot that ray from the gun. So far, you haven't seen what a ray is. I guess we're going to set a way to visualize it so it's easier to see it. So go to the update function here and do debug. So basically debugging is an easy way to, I guess if you want to check if there's any bugs or if it helps you check things in the editor. So do debug, draw ray. So if you want to draw it to see it on the screen, open bracket. And then we have in the draw ray, it has the same thing as the raycast that you saw. There's an origin, direction, we can set a color, and how far it goes. So we go in nozzle, transform, position, and then we set that's the origin. Now we want the direction, which is nozzle, that transform, forward, since that's the direction we're shooting, and comma, we want to set the color for it. In this case, we can set color, which is a class, dot red. One thing, we should also set the size of that raycast. For now, we'll set it, so we'll multiply it by 15. So it's going to be size of 15. We'll close that. So now if you go back to the editor, I want you to go to your screen and turn on this gizmo option right here. What basically this does, it should already be on, is viewing all the options for the editor and any interactable items. They're only viewed in the editor. So if I go start, oops, one thing, I want you, all these should be checked, of course. And oops, should be here. 3D icon, selector, outline. All right, and it should be fine. Now, if you play the scene and go in the scene view, it should there it shoots the ray, but does not shoot it correctly. I think we need to change the direction of the ray. As you see, that ray is the direction we're shooting. Oh, press escape and you're gonna see your cursor. Go here in the game and press gizmos. Now you see the imaginary line where we're shooting. So that's where we're going to be shooting, and that line has to hit the object that you see right here. So this is why we have this line, because we want to detect where the gun is shooting and what is shooting in front of it. So again, press escape. You're going to see an option called gizmos. So just turn that on in the game view as well. So now we know where the ray is shooting towards. Well, we want to also set what's going to happen to the object when it's hit. So what we want to do is we want to find that. Now, all this is going to be done through the rigid body of the target. So what we want to do is rigid body in the function. We're going to call it RB just for simplification. We're going to do hit, transform, get component, rigid body. All right, so we've referenced in the rigid body. Now we're going to get that hit vector that we have. So we're doing, well, we can write var, which is a default type that automatically figures out every ray. Hit vector, we're going to name it like that. And we want to find the direction from which the hit came from. So basically what we want to do is, if a ray is shot from here to the object, we want, and that hit over there that hits the object, we want to make sure what the direction of that hit is and where does it come from. So we're doing hit dot transform position minus the origin of where the bullet came from. Now we want to do normalize, which it takes into account the direction. This turns it into a direction pretty much. So we have the hit vector, which is getting the direction of the hit, and then we want to apply. Our goal is to add interaction to that to the target, or force pretty much. We want to push that object. This is why we're doing this. So doing RB, which we reference to the rigid body, is a function called add force. So this is going to add force to the object. So like we said here, like the movement earlier, we want to get the direction, so hit vector, but we want to multiply it by magnitude, which is the amount of force the gun is pushing. But we need to set a variable for that. So we go into the shooting properties that we already have here, and we're going to set the force that we want to shoot. So we're going to make it public because we want to edit it in the inspector. Public float force. And we want to multiply it by that force because that's the amount of force the bullet applies to the gun. But we also want to turn that object while it's hit. So we can rigid body, add torque because we want the object to turn, hit vector, multiply by force, which is the same as the force that we add. So now if we go back to the editor, Should compile. Go back to the gun and you're going to see force here. We're going to set it to, let's say 800, which is the force that is applied. So we set that. See if we have anything else that we're missing. Oh yes, we need to reset the shooting cooldown. So make sure we reset the timer when we're shooting. So that's easy. That's going back here and doing shoot cooldown, shoot rate. So when we finish our shot, we make sure we reset the shooting timer so we're able to shoot again. So you save everything, go back. So what should happen now if I shoot? It pushes the object. So we finished much our shooting mechanism. So it shoots the gun and it pushes the object. And as you can see here, if you want to see your current clip size to make it easier, go back to the gun and turn it into public. So Control S to save again everything. It's going to, and now we have the current clip size. It's 0, but when we start the game, it starts at 7, and now a shot, it goes down to 6, 5, 4, and now I should shoot 3, and well, bye-bye. So I guess to make this more fun, we can set up more targets. So we can, if you want to create a new object, use the same one, Control S and Control V to paste it while selecting the cube. Another way to do this is Control D. So you select and Control D to copy paste it right away. So what I want to do is have the cube selected in the hierarchy, Control D, and it makes a clone of it, a copy of it. So if you move that, we have 2 cubes now. We can change, of course, the size, set it to 5, and we can make it heavier. So we go down to the rigid body options for having the second cube, and we can change the mass to 5, so it's a bit heavier than the other one. And what we can do now is set another object. So right click, 3D object. We can add a sphere. And we have a primitive sphere right here. And when we select the sphere, go back, rigid body, go back, we place it in the scene. I want it. But let's play around and add some more options. Let's try to let's make it bigger. So let's set it to 3. I want to demonstrate why do we need the rigid body component. So what I'll do is I'll make a new sphere, so Control D, and I'll remove the component, and I'll explain to you why it's important. So if I go to the sphere to simulate the difference, I'll drag this sphere with the rigid body on the hill, and I'll drag this one as well here to see what the rigid body does exactly. So if I press play, as you see, the one with the rigid body is actually rolling down because it has physics on it, while the other one, it just stays there and is not going to get hit. If I hit it, nothing's going to happen because it does not have a rigid body component. So as you can see here, we have the sphere. It rolls around. So if I hit it, oops, I turn. Oh, what you should do for the sphere now, I forgot, is select both. So select the sphere here. You have to set the target tag, which we said is one of the conditions that we have for shooting. So if you press play, now we're shooting. Sphere rolls down, shoot it, add a force to it, keeps pushing. So if I hit the box, this is heavier now because we have a higher mass to it. I put it to 5, so it's a lot. So if I keep pushing, it's harder to move it. But this one is lighter because it only has a mass of 1, and this one has a mass of 5. And this is what rigid body physics do. And pretty much, this is a tutorial. I guess this is what I have fun. And I hope you follow along and you're able to replicate it. Of course, I'll stay a bit more for questions if anybody has questions in the chat. And I hope you finished your first, this is your first Unity program. And one thing I realized I did not add for this tutorial is I don't have a correct movement, like a correct movement. I should have done that, but it's fine. Let's see if we have any questions. Yes, so pretty much we're done. If whoever wants to stay, I can show you how to add like gravity for the player as well. So the player, when he goes to the ramp, he's also able to go down, back down. But I can do that real fast right now, if that's not a problem. We can, this is why, if you go back to the capsule, just as a bonus thing, remember that we set an empty here in the beginning that checks, that's at the bottom of the, it's at the bottom of the player. If you haven't set that already, just player, right click the player and create empty and just drag it at the bottom of the player. What I want you to do is make a new reference for it here on the script, player movement. I'm going to call it transform. I'm going to call it ground checker. So you're going to check if the player is touching the ground or not. So like we did for the nozzle, same thing. Go to the player. I did not set it. I need to set it to public because I need to reference it in the inspector. So go back to player. You see here ground checker. Just grab that empty, put it there. So we have that. It's already referenced in the inspector. And we want to create a new function called check if grounded. So this will have a switch variable that checks if the player is touching the ground or not. So we can create a new switch called bool. So boolean is grounded. And this now it will check if it's true or false all the time. So we do is grounded. And now we check physics. And now what we do is we create a function called overlap sphere or overlap capsule. We can do sphere in this case, overlap sphere. And now we do. It takes into account the position of the empty that we want, the radius of the check of the player, and also the layer mask. I'll show you what it does basically. So we're going ground, check, the ground checker, position. Now the radius of that circle, we're going to set it to a really small variable since we already have a collider to the player, so 0.1f. And we want to set the layer mask. Basically, a layer mask is it detects if that object is a ground or not. If that layer, because basically layers are, if you go back to the scene, you're going to check that there's layers here. In this case, we have a default layer for every object pretty much. But, so basically, oops, you want to, no, cancel. So basically, we want to set a layer mask for that object that checks whether it's touching the ground or not. Doing layer mask. Oh, layer mask, yes. Get mask. Ground. So it's going to check if it's a ground object or not. Length, and we're going to see if that, if the distance between the overlapping sphere and the ground checker that we have is penetrating one another. So we have to check if it's bigger than 0. So if it's bigger than 0, this will be true. If it's smaller than 0, it's going to be false. So basically, this is where we check whether the player touches the ground or not. So basically, I guess to visualize this, the player will try to touch the ground. So right now, the is grounded is false because it's not touching the ground. But if it does, it penetrates, this is true. So this is basically what that purpose is. So now we want to check that every frame, because every frame that's when the game changes. So check if grounded. Same way for moving player. So if I move now, I should be able to fall down. No, I'm missing something. I should check at least. No, it does not. So what we need to do is real quick is, oh yes, in the player movement, in the move player function, where we move the player, we want to check if it's ground or not. So if it's grounded, we're going to simulate gravity to the player. So player move, which is vertical movement, so vector 3. In this case, the y-axis, which is up. And then we're going to multiply it by the gravity, which is minus 9.81 f. And then time dot delta times. It's just a movement. You always want that. So basically, this checks if the player is not grounded, you simulate a gravity movement to the player. So if I go here, just almost done. If I go up the hill and I fall down, I fell down. So here's your complete game. Hope you had fun, and hope you're able to continue yourself and add new features or anything you want. Hopefully, it motivated you to try new workshops and try more Unity tutorials. And we also host in our group a lot of workshops for us. We're going to have another one this next week. And in the Concordia Game Dev Club, we're trying to host workshops every few weeks or so. So if you want, join our club, and hopefully, and thank you, of course, thanks the SCS Society, like the SCS, for hosting this workshop. And I'd like to thank also Matthew for helping me set up the stream. So this concludes the tutorial. I hope, yep. We'll also have the finished project will be on the GitHub link. I'll make sure I upload the current changes on GitHub, so you can play around with it. And also now this session, and now also everything should be fine. I guess it's over now. I can stay around for some questions if you want, but I'll post the GitHub link. I'll update the GitHub so it's ready. And this concludes everything. I'll just finish right about time as well. So, yep. Good night, everybody. I hope you have a good night, and also hope to see you in other workshops. I guess I'll be closing the stream now. So if you have any questions, and you can join our Discord, and if you have any questions, you can ask us there as well. Anything else related to SCS, you can ask the SCS moderators, of course. So, good night, everybody.